we are going to talk about the quadratic equation. What is it? It's an equation that allows us to solve equation of the second degree and calculate the root of quadratic function. Below you can see the quad equation. ax squared plus bx plus c is equal to 0. It's composed by three different terms: a or quad term, b or linear term, and c or constants. Finally, that formula is solved by applying the resolvent formula or Bhaskara formula.
The first condition is that the equation must be equal to 0 and order the terms. Then you have to identify the variables that you are going to use in the formula and replace them. When you have already replaced them, you solve the rest. First, you get the result of negative c squared and perform the following multiplication. Then you have to subtract the result from before and do the square root of them and simplify the result. Finally, you must interpret the positive or negative sign. This is important because it means that there are two possible solutions. One is positive and one is negative, and both are the solution. Bhaskara was an Indian mathematician and astronomer known for being the creator of the quadratic or resolvent formula. He was born near Vyadabhida and became head of the Ujjain Astronomical Observatory, continuing the Matemática tradition of Varaha Mihira and Brahmagupta. Bhaskara represents the peak of Indian mathematical and astronomical knowledge in 12th century. He mastered calculus, astronomy, number systems, and solving equations which had not been achieved anywhere in the world for several centuries.
The graph received the name of parabola. X-intercept are the intersection point of the parabola with respect to the x-axis. It allows us to solve equation of the second degree and calculate the roots of a quadratic function. It's solved by applying the resolvent formula or Bhaskara formula. Vertex, the maximum or minimum value highest or lowest point of a parabola. Its coordinate can be solved with the following formula. So, the x-coordinate of the vertex is just equal to negative b over 2a, and the y-coordinate of the vertex is just equal to c less b squared over 4a.
Axis of symmetry, also known as a line of symmetry, will divide the parabola into mirror images. The graph calculates the coordinate of the vertex and then arms a table of values taking into account the condition of symmetry.
The first expression was the polynomial expression. What you have to do in this one is to place all the components of the function in their place. First, we identify a, which is going to be the x squared. The x that is alone will be b and the natural number will be c. The second expression was the canonical expression. To start with the sample of the function, we must find the values of xb and yb. First, we start with the resolution of xb using the formula in the image. Once we have found its value, we are going to solve yb, also using the formula in the image. When we have the two results, we will only have to build the function as follows. The third expression was the factor expression. For the formula of the factor expression, we need to find the values of the roots. For that, we are going to apply the resolvent formula. After finding the values of x1 and x2, we will set up the function as shown below.
Today, our group will be explaining and showing how to solve 3 examples of the topic that the last group explained, which is second grade equation.
Example 1. First, we solve the square of a binomial, x minus 6 squared. Then it goes, the first one to the square plus 2 times the first times by the second, plus the second to the square. We copy the minus 2 and then we must multiply a binomial to its opposite, x minus 6 times x plus 6. And then we move the terms to the left with their opposite signs. This will look like this. Then we have to solve the multiplications and squares, and then apply the distributive property. The terms that can be solved are copied again. It would be: we solve the additions and the subtractions. We apply the resolvent formula and we solve it. We find the two values of x that are the solution.
Example 2. First, we solve the square of binomial, x minus 7 to the square. Then you have to do the first one to the square plus 2 times the first one to the square multiplied by the second one plus the second to the square. Then we copy minus 2 and we have to multiply a binomial to its opposite. In parentheses, x minus 5, close parentheses, multiplied in parentheses to x plus 5, close parentheses. And we pass the terms that are at the right of the equal sign to the left with the opposite signs. Lastly, we solve the potencies, the roots, multiplications or divisions. That way it's all clear out, just sum the terms. When you have to sum the terms, you have to take into account that all x's have the same value. That way the x to the square are summed with the x to the square, the x with the x, and the independent terms with the independent terms. When we have to apply the resolvent, we have to take in consideration the following. In the show with equation, there are three different terms: a minus 1, b minus 11, c 80, which are going to be located in the following way. So it will look like this. When we solve this, we start passing the minus 11 to positive and multiply the terms that we are left inside the root. We also solve the potencies. Lastly, in this step, the 2 multiply minus 1 in parentheses is multiplied, so it will look like this. Then we sum the terms inside the root to finally solve this. Now, lastly, we solve until we get the final result.
First, we separate in terms. Then the parentheses are solved. In this case, it starts with the square of a binomial, 7 minus x squared. The first number to the square plus 2 times the first time by second plus the second square. Then the second term is solved with the distributive, x minus 5 times x plus 5. And the numbers without parentheses don't change. We solve the parentheses that were left from the distributive and we equalize all the equation to 0. Finally, we put together the numbers that don't have an x, the ones that do have, and the ones that have x squared separately and use the result formula to separate x1 and x2.
In this presentation, we are going to talk about the quadratic function. The quadratic function is a second-degree equation whose general expression is f of x equals a times x squared plus b times x plus c. In the general expression, we can find three different parts.
One is the quadratic term, which is a graph of a quadratic function in the form of a parabola which opens up if a greater than 0 and opens down if a less than 0. The second part is the linear term, and the last one is the y-intercept of the graph of a quadratic function is 0c, and it is called constant term. We already talked about the general expression of the quadratic function. Now we are going to teach you how to graph a parabola by only having the general expression.
To know where you have to mark the x-intercept, you need to solve the following equation. X is equal to negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Another important part of the function is the coordinates of the vertex, which are the maximum or minimum values, highest or lowest points of a parabola. These coordinates can be solved with the following formulas. X is equal to minus b over 2a, and y is equal to c minus b squared over 4a.
If the discriminant is more than 0, there are two solutions. If the discriminant is equal to 0, there is only one solution. But if the discriminant is less than 0, there is no solutions.
We are going to talk about the system of mixed equations. We call system of mixed equations to the whole system of equations where at least one of them is not linear. This system can be solved analytically through substitution and equalization methods or graphically. In this case, we will show you how to solve it both ways. Before the example, we want to clarify what it means to solve analytically and graphically. Analytically solving a system of equations means finding the values unknown that simultaneously verify the equations of the system. Graphically solving a system of equations means finding the intersection points of both graphs. Also, the analytical resolution can be verified through graphical solution. Now, let's go with the sample and the steps to solve a system of a mixed equation in both ways. Example: y equals 2x squared minus 8. Y equals x squared minus x minus 6.
We can solve it analytically by following the step below. Step 1. We have to use the most convenient solution method. In this case, we will use the equalization method that equals y with y. So, y equals y. 2x squared minus a equals x squared minus x minus 6. Step 2. Match the equation to 0 and modify the sign accordingly. 2x squared minus a minus x squared plus x plus 6 equals 0. Step 3. Solve and identify a, b, and c. 2x squared minus a minus x squared plus x plus 6 equals 0. X squared plus x minus 2 equals 0. A equals 1, b equals 1, c equals negative 2. Step 4. Now that we have a second degree equation, let's solve with the following formula. X equals negative b plus or minus the square root of b squared. 2 4a minus 4ac all of that over 2.
X equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 2 over 2 1. H equals negative plus or minus the square root of 9 over 2. H equals negative 1 plus or minus 3 over 2. H1 equals negative 1 plus 3 over 2 equals 1. H2 equals negative 1 minus 3 over 2 equals negative 2. Step 5. Once we solve the second degree equation, we replace the result in the original equation. H1 equals 1 where 1 equals 2 times 1 squared minus 8 equals negative 6. H2 equals negative 2 while 2 equals 2 times negative 2 squared minus 8
equals 0. The intersection points are 1 minus 6 and negative 2, 0. We can solve it graphically by following the steps below. Step 1. Identify A, B, and C from each equation. Y equals 2x squared minus A. A equals 2. B equals 0. C equals negative 8. Y equals x squared minus x minus 6. A equals 1. B equals negative 1. C equals negative 6.
Step 2. Find out the vertex of x and y with the respective formula. xb equals negative b divided by 2a. xb equals 0 divided by 4 equals 0. yb equals f, xb equals a times b squared plus c. f0 equals 2 times 0 squared minus 8 equals negative 8. xb equals 1 over 2. yb equals a half squared minus a half minus 6. yb equals a quarter minus a half minus 6 equals negative 25 quarters. Step 3. Once the values of xb and yb have been obtained, we have to make a table of values for each equation. If x is equal to negative 2, y is equal to 2 times negative 2 squared minus 8. If x equals negative 1, y equals 2 times negative 1 squared minus 8. If x equals 0, y equals negative 8. If x is equal to 1, y is equal to 2 times 1 squared minus 8. Then, if x equals negative 1, y equals negative 1 squared plus 1 minus 6. If x equals 0, y equals 0 squared minus 0 minus 6. If x is equal to a half, y is equal to negative 25 quarters. If x is equal to 1, y is equal to 1 squared minus 1 minus 6. If x equals 2, y equals 2 squared minus 2 minus 6.
Now we are going to see how a quadratic function works and how to analyze it. To do so, we would like to show you three examples and explain them. In the first one, we have the general expression g with x in bracket is equals to ax2 plus 24, and we know that for the function g defined above. A is a constant and g with 4 in bracket is equals to 8. Once we know this, the question is, what is the value of g with minus 4 in brackets?
Now this is pretty simple. If you pay attention to the exhibitions, the J, K thing we need to replace the X with the number between parentheses into the equation, we need to take into account the Gx is a constant of a, if we know the value of a, know the answer. I would be equal to 8, so the answer is the first one. In the second example, we are asked to find equivalent expressions of the vertex in the xi plane in the canonical form.
Now we know that the equation of the graph is y equal x2 minus 2x minus 15. So we have to find an equivalent equation that agrees with the conditional stated in the problem. First, we need to focus on the A, the B, and the C of the equation. In this case, A is 1, B is 2, and C is 15. Knowing this, we can start searching to conical form of the equation. To find the value of x, we need to use the formula xb equal minus b over 2 times a. It will be minus 2 over 2 times 1, which is equal to 1. Now, y equal ax2 minus bx plus c will be 12 minus 2 plus 1 minus 15, which result is y b equal minus 16. Now that we know all the parts of the equation, we just have to replace the term with the values. Y equal x minus 1, 2, minus 16. So the correct answer is option D.
Now, the third example is tricky because the problem doesn't tell us which is x and which is y, so we need to interpret the question to find the expressions that we don't have. The question states that h is the term of the approximate height of a ball which is launched vertically upward from the ground, and t is the term of the seconds that the ball stays in the air until it touches the ground with a speed of 25 meters per second.
Now that we know this, we need to find how many seconds the ball will be in the air until it touches the ground. So, if h is the height of the ball, we can infer how to calculate the distance. In order not to get lost, something must be clear. Although in each problem the term can vary, there is always one y and one x. So what we have to do is place them in the example according to the way the problem is started. In this case, h will be y and d x. We finally wrap it in a generic expression that is h equal minus 4,9 multiplication t squared plus 25 multiplication t. To know how much time the ball will be in the air, we must calculate the roots of the function applying the resolvent formula and finding the a, b, and c values. The result is t equal 25 plus or minus the square root of 25 squared minus 4 multiplication 9 multiplication 0 over 2 multiplication minus 4,9. And after solving this formula, the result is 0 semicolon 5 comma thin. So D is the correct answer.